Hey, it's me, Miss Wesley again. I thought we'd be able to just kind of finish up your notes for 2-4B for these tougher chain rule problems and get some extra practice in and get a head start on your homework problems. I thought I could give you a little bit of guidance as you're trying these practice problems on pages 12 and 13 of your differentiation packet. Let's start with the tough one. Look at 8. 8 reminds me of the one that we just tried, but I've got different powers on top and bottom. So a binomial to the fifth over a binomial to the fourth power. You've got some options here. I'm going to try this by quotient rule just to give you guys one method that could work pretty well. And we have to keep track of all parts of this, and we're going to need a lot of space. So we've got derivative of the top, that goes first. So this is derivative of the numerator. Let's use a chain rule and deal with the fifth power first. So 5 times x plus 1 raised to the fourth. Then technically we've dealt with the 5 and we're supposed to go inside and take a derivative of the x plus 1, but I feel like that's already handled. Your inside derivative is just 1, so no need to write anything after that. So it's the top numerator derivative multiplied by the bottom normal, so the 1 minus 2x to the fourth, and minus because we're in the middle of a quotient rule. Now let's reverse what we just did. Let's take the derivative of the bottom, dealing with the 4 first, times the normal numerator. So here goes the fourth power swinging down. This whole thing is raised to the third, so 1 minus 2x to the third, times, now let's go inside and multiply it by an inside derivative of negative 2. So this is derivative of the denominator times the normal numerator. So that was x plus 1 to the fifth, and phew, we've got our numerator taken care of. Now let's go into the bottom. This should be a little bit quicker. Quotient rule says you take the normal denominator and you square it. So this thing was raised to the fourth. Let's double that when we square it and raise this to the eighth. Again, 20-second ruling is fine here. Yeah, maybe you're going to make these a negative 4 times a negative 2. You might make those a positive 8 coefficient. Another thing I want to show you that you can do that could help us in the future is there's a little bit of canceling that we are allowed to do. Do you notice if you consider these three parts, so this part, and this part, that they actually do have something in common? They all have a number of powers of 1 minus 2x. So optionally, we actually could cancel 3 of these powers out of all 3 parts. I can get rid of this completely, leave a 1 in its spot. As long as, look at me crossing out 3 of these, I can cross off 3 of those 4 and leave only 1 left over. And then I had 8 of these on the bottom, I can get rid of 3 of those as well, leaving the fifth power here. So I want to show you another way that you can optionally write it just as a simplification option. So we'll make this, what do we have left? 5, x plus 1 to the fourth, stays there, and 1 power of 1 minus 2x. Minus, or how about plus, right? Negative 4 times negative 2, so plus 8. I think all I have left is x plus 1 to the fifth. That should do it for the numerator. And denominator can simply be 1 minus 2x raised to the fifth power. So I can leave it in either one of these ways. Now, what about your homework questions? There are times, like I'll give you advice on 9, 10, and 11. Don't do these by quotient rule. Solve them like we solved some questions on the other side of the packet. So like if I were to go to do number 9, my very first step is swinging up this denominator and writing it to the negative 1 power. So it's 5t squared minus 6t plus 2 to the negative 1 power. It'll be much easier to take a derivative now just using a chain rule instead of having to think about quotient rule. I give you that advice in 9, 10, and 11 because the numerators are just constants. There's no x in the numerator, so it makes it really nice to just rewrite and swing up the bottom and proceed from there. You're going to see that's a little bit different as you look down the page. I want to try one more that I think looks a little bit tougher. So product rule here, this one might be a good one to try. Some quotients where I wouldn't, like maybe the last 2 we could try would be, I like 13 and 14. For 14, here's a quotient that I want it to stay a quotient because you have x's, variables, on the top and bottom of the fraction. So let's end here. Let's look at 13. For this homework question, I have a product rule, right, of this times that, f prime of x. And if I think back to product rule, this is good practice. I'm supposed to take the derivative of the first part times the second part normal. So let's do that. This is a good chain rule opportunity. You're thinking, okay, your main event is that this whole thing is raised to the third power. Let's deal with that exponent first. So we'll swing down a 3, write x plus 2 to the second power. Then we think, okay, we dealt with the cubing. How about we deal with the inside? Inside derivative is just 1. So you don't even really have to write it. You can multiply by 1. So that's f prime. Now we write g normal. Okay, so this is times 2x minus 1 to the 5th, unchanged. Product rule this time, I'm used to writing a plus in the middle of it, unlike the quotient rule. So now we reverse things. Let's take the derivative of this second part. So start with the 5th power. So 5, 2x minus 1 to the 4th. And now let's look inside. We've dealt with the 5th power. Now we deal with the innermost part and take a derivative of 2. We get tagged on there as well. So that is g prime. And we've got to put f normal. The original first part normal, so that would be x plus 2 to the 3rd. And that's it. Those are all parts of your product rule. There's only one little measly thing I would change about this. Again, I would just make these two a 10 instead of saying separately a 5 times a 2. And we really don't need this one. So the way to leave it would be a 3 times an x plus 2 squared times a 2x minus 1 to the 5th, and then plus 10 times all this stuff. 2x minus 1 to the 4th, and then x plus 2 cubed. Okay, one for the road. Just looking at the next problem, number 14 has a big square root around an entire quotient. Let's try this dealing with the main event first. First, let's deal with the fact that the whole fraction is raised to the 1/2 power. This is 3x plus 1 over 2x minus 1, all to the 1/2 power, like this. Okay, so now g prime of x. Now it's our job to take a derivative. And like we said, let's deal with that outermost part of the function first. Let's deal with the 1/2 power. So let's swing it down front by product, or power rule, I'm sorry. So 1/2 comes out front, and the whole fraction is going to be raised to the negative 1/2, 1 power lower. On the inside, we just recopy that original fraction, 3x plus 1 over 2x minus 1. Okay. Next part, times. Now let's go inside. And I think your best bet is to do a slow and careful quotient rule on the inside of this function. So we had 3x plus 1 up top, and the derivative of that is the number 3. Next to it, let's put the 2x minus 1 normal. So 2x minus 1. Okay. Minus because we're in the middle of a quotient rule. Now derivative of the bottom, which is just 2, times the top normal, so times the 3x plus 1. I could barely squeeze that in there, but we'll simplify it in a second. All over the original denominator, but squared. So this will be 2x minus 1 squared. In this case, there's not really too much that needs to be simplified. You can pretty much leave this as is in terms of the 1/2 can stay a 1/2. This whole fraction's to a negative 1/2 power. I'm also fine with this. 3x plus 1. And then a 2x minus 1. But how about just what I originally wrote in blue up here? How about we clean that up a little bit? So I'm going to leave the 2x minus 1 squared on the bottom. And then let's do some side work with the stuff in blue. So distributing in, we have 3 times 2x, so 6x minus 3, that 3 going to both parts, and then minus 6x, I believe minus 2. So the 6x's canceling, and then you just ending up with that part of the numerator being a negative 5. This looks fine. So these are definitely more complicated than your average derivative problems, but work through them. Ask yourself, which rule would be good, right? Do I want to quotient rule this and just be really careful about it? Do I sometimes need a product rule with chains within it as well? Keep the questions coming and keep up the good work. I will talk to you soon.